Now, excited to be here today to present this study on the OWASP top 10 vulnerabilities in GraphQL. Okay, so thanks for coming here today to listen to our talk. Learn.Escape, we are a GraphQL security company, an API security company, and we built the first automated security testing platform that is able to test the business logic of APIs, and more specifically of GraphQL APIs, because we have a very strong focus on GraphQL at first. In this study, we are going to present the results of an analysis of more than 1,500 production GraphQL APIs that we scanned in the wild, on the wild internet, that we detected, who are public APIs. It took us more than 400 cumulative computation hours to get the result of this study. So this is a very serious research that we did. And we found in total more than 40,000 security alerts in those 1,500 production API that we scanned. So this is a quite consequent result. So on average, we found almost 30 security alerts per GraphQL app. And please keep in mind that those were scans that we did in a completely unauthenticated manner on the wild internet. So the result is pretty impressive compared to the low touch that we made on the GraphQL endpoint. So I'm Tristan. I'm the co-founder and CEO of the company, and I'm speaking today with my co-founder Antoine here, who is the co-founder and CTO, and can give a glimpse on the technical details on how we created those results. And the full result of this study can be accessible in the State of GraphQL Security report that we published a few weeks ago. So now I will let Antoine start about why is GraphQL specifically vulnerable compared to other kind of APIs before we jump into the results.
Okay, so thank you very much, Tristan. So indeed, the first question we have to ask ourselves actually is why is GraphQL so vulnerable? So first things first, GraphQL is a query language for database that is used in production by companies in every Fortune 500 verticals, such as retail, finance, travel, and so on. And this mainly thanks to its amazing federation capabilities that allows to combine multiple API sources together, whether they are REST, GraphQL, and so on. So GraphQL is an amazing query language, but with great features comes great responsibilities. Indeed, every single of the GraphQL specific features we can see here is in fact also a potential source of vulnerabilities. In addition, GraphQL is a graph. So it connects resources together. And in particular, one single resource can be accessed by a massive number of different paths, which makes access control very difficult to ensure in GraphQL applications. Okay, so the second thing that is really important to understand is how much hard it is to test GraphQL APIs. And why is it hard to collect the data we are going to present you today in this speech? And the first thing to understand here is that if we simply test dynamically an API using random payloads, we don't pass the data validation layer, and therefore, so the requests, they don't pass the data validation layer, and therefore they cannot really assess the business logic of an API. And especially from a security standpoint, it would not make a lot of sense. This is why we developed a unique technology that we call feedback-driven API exploration that is able to test APIs, GraphQL APIs in particular, with a super high coverage. It does not require any agent or no traffic capture, so it does not access the production data of the customers. So to illustrate, let's take the example of an e-commerce platform with two kinds of users to explain why assessing the business logic is really important. Imagine in this e-commerce platform, you have two kinds of users. First are sellers that should not be able to see, to see the orders of all the customers. And the other category of users are buyers that should not be able to see the orders of other buyers. So to test that business logic case, this required to have a running application that has at least one seller, two buyers, one product on sales, and two pending orders from two different buyers. So with our unique feedback-driven API exploration algorithm, we generate the legitimate requests that can test this situation, and this at every update of the application. The second thing, again, is that GraphQL is a graph. Okay, so the algorithm that can assess the security of GraphQL application must ensure to test the conditions are valid for every single pass in this graph again. Okay, so what about the findings? We found almost 50,000 security alerts during our different scans, and it happens that 10% of them were of critical severity. Here, we created our own classification that makes more sense according to GraphQL ecosystem, and here is the mapping with the OWASP top 10 23. And very interestingly, we can see that three main categories of vulnerabilities are actually emerging, and this is what Tristan is going to explore now with you.
Thank you, Antoine. Yes, exactly. So first, let's break down the different vulnerabilities that we found during this study. And first, what we can observe is that a lot of them, the most frequent ones actually, are GraphQL specific. They are specific to GraphQL. So let's take a quick look at what it looks like. If we take a look, we see that the three first major vulnerabilities are complexity one, and denial of service and information disclosure through exploiting features of the GraphQL language. So let's take a deep dive into that. So the first vulnerability, the top vulnerability that we found in most GraphQL endpoints is brute forcing API requests through what is called GraphQL batching or aliasing. So GraphQL has a feature which is called batching or aliasing that allows to send several GraphQL requests in one single HTTP request. And this can be abused to bypass the API rate limitations, because you can send multiple requests in one single HTTP request. And if the rate limitation is made at the HTTP level, it will just miss the real number of requests that you are sending. And this is a problem because it can be exploited to brute force the API and, for instance, brute force authentication. So we can see that on the next slide. Yeah, exactly. So for instance, in this case, I can send multiple login requests with the same in a single HTTP request using GraphQL aliasing and test multiple combination of usernames and passwords and try to find the right combination. So this is a very important vulnerability that is entirely specific to GraphQL and that you should care about if you're building GraphQL for production. The second one is denial of service again through fragments. So fragments are a piece of logic that can be shared between multiple queries. It's kind of like a function in GraphQL or a template. But the problem with fragments is that if you create a fragment that calls itself, so a recursive fragment, it can lead to an infinite recursive loop and crash the GraphQL server, which is what is displayed on the next slide. So yeah, exactly. Here we can see that we created a fragment, and this fragment X calls the fragment Y, and the fragment Y calls the fragment X. And if we launch this query against a GraphQL server, we can see that it will reach the maximum call stack size and crash the GraphQL server, creating a denial of service and consuming a lot of resource. So again, this vulnerability is one of the top vulnerabilities that exist in GraphQL, and a lot of GraphQL servers are vulnerable to it in the wild from what we observe in our study. And then the last kind of vulnerability that we found is the internal API schema leak. So in some cases, when you are not creating a public API, you don't want to show the schema of your GraphQL endpoint, of your GraphQL API. You don't want to disclose what are the resources that can be fetched by the client. So you disable what is called in GraphQL the introspection that enable your clients to understand what they can query using your API. But the problem is there is a feature in GraphQL which is called the field suggestion, which is like suggesting you possible queries if you made a typo in a name. And this feature stays activated even when you deactivate the access to the schema. And if you use this to brute force, you can actually build back the real schema by fuzzing possible inputs and fetching the suggestions that the GraphQL server sends you back. So in this example, for instance, the example that I was showing, we see that we were able to build back a full schema of the API that is displayed. So this was not supposed to be accessible, but we were still able to build it back. And we can see that there is an update admin mutation, so the equivalent of an update admin post request. And this one was actually not protected using authentication because it was believed to be completely hidden. So we were able to manipulate the administrator account of this API. So we took a quick review of the different vulnerabilities that are specific to GraphQL, but classic API's vulnerabilities are still there, and we can still observe several of them among the GraphQL endpoint. So there are a lot of HTTP level errors, so server errors, unhandled server errors. We have a lot of stack traces that disclose too much information in the different endpoints. And we have also access control problems and injections, which are still quite common among what we found in the API. So API error and stack traces, disclosing internet data. So why is that a problem? A stack trace happened when you didn't handle properly an error in an API call, and the error message is sent back to the client. The problem with this practice is that the stack trace generally gives a lot of information about your code and probably about the libraries that you are using in your API. And one can leverage the open source database of vulnerabilities intelligence in order to understand if you have vulnerable libraries. So in this case, we can see a stack trace with a GraphQL error that shows that this person is using the gateway with a specific version. And this gateway, we can see in the vulnerability database of open source libraries that it has vulnerabilities that are known and that are affecting this specific package. So we have an attack vector there. The second problem is the access control issues. So we found a lot of routes, for instance, post routes, or in the case of GraphQL, mutations, which are the API routes that can be used to edit the content in the database, to edit resources. And those mutations were not protected. Nobody needed an authentication token to use them, which means that any unauthenticated user can perform operations on the database that changes the state of the database. So this is probably an access control problem, and it's often overlooked. And finally, injections. So injections are still there. We found 16 SQL or no SQL injections during the study, and one bash command injection. So believe it or not, but bash command injection in blind mode are still a thing, and 3 server-side request forgeries. So this is something that also must not be overlooked because it still happened in GraphQL APIs in 2023. Finally, last but not least, we found sensitive data that was made public in those API. And we found a pretty large amount of it. So this is something that must be taken into account when you're exposing API. So what did we find we found more than 4,000 different potential PII and token leaks. We found, of course, emails, phone numbers, but also API keys, AWS token, and so on. So if we take a look, if we break down by frequency, by the amount, we can see that what we found much more was emails and phone numbers, so probably PII, passport number as well, and then what's even worse, API keys. So we found AWS, GCP keys, we found private RSA tokens, we found specific API tokens for Adobe, for Asana, for GitHub, for Slack, for SendGrid, so for several services. All those tokens were mostly present in error messages from the API, so they were sent in error messages directly to the end client. So if we wrap that up through the lens of OWASP top 10, we can see that there are a lot of denial of service and potential complexity issues in GraphQL if it's not configured properly. So it's API 04, unrestricted resource consumption that's present here. And then we have a lot of vulnerabilities linked to API 01, API 02, API 03, and API 05. So everything that is like broken object level, function level authorization, or broken authentication. This is very complicated in GraphQL due to GraphQL's graph nature, which makes it pretty hard to handle from an authentication and authorization point of view. And then we have a lot of security misconfiguration and information disclosure. So API 07, security misconfiguration. This is because by default, the GraphQL engines and most GraphQL engines that exist are very permissive in terms of what they accept, the queries they accept. So you have to put the good security defaults on a new production GraphQL server in order to avoid accepting too many queries, including queries that are malicious and that could lead to problems in your production environments. Okay. So to conclude, you can find the results of this study again in the state of GraphQL security. So feel free to take a look if you want to have more details about the breakdown of the findings that we had. And if you want to have a quick highlight of the results. No, I think
it's the end of the.
Okay, this is the end of the presentation. Sorry, I thought we had one more slide with the result, but we don't have it. So thanks for listening to us. We are happy to take a few questions because I see we have like 6 minutes left, something like that. So happy to answer questions.
Yeah.
So first question from my side, how did you find out about all these things? What was the way you researched all of this and looked at it? I mean, I'm pretty stunned that there, for instance, so many people put keys in their GraphQL system. I mean, it's still mind blowing that now 2023. These things happen. But how did you do the research? What was your way of gathering this information?
Yeah. So we have an internal team that is led by Antoine, actually, that researches the 0 day in GraphQL engines and in GraphQL APIs. And what we did is we used bug bounty programs in order to test and to try to learn what are the common vulnerabilities. And also, we did research on the engines themselves. So we took a look at the code of the GraphQL engines themselves. We tried to manipulate them in every different way possible in order to find vulnerabilities inside of them.
And what is important to notice here is that the study was made on production-ready GraphQL endpoints that were publicly available on the internet, but that are qualitative GraphQL endpoints. I mean, GraphQL endpoints used by real companies that are sometimes famous, and it was just a very, very passive way to collect this data. And what is very strange is that just by doing some unauthenticated requests, non-destructive requests that are just reading things, you can very easily collect all those tokens and sensitive information in a very passive manner, and that's what is quite frightening in GraphQL, I would say.
Yep, it is, but it's even more frightening if you say like most of these or a bunch of these things were just open, accessible
Absolutely.
GraphQL databases that you could just access. I mean, it's already a thing if it is there, and all these things are there in a so much private thing for a huge company, because hey, internal threats are just as important as external threats. But if you put keys in, and that was the most one that was so mind blowing to me. Like, okay, I get it that there is the things that you can use multiple ways to try to log in, but that you put keys in it still, that people still do that. That's like amazing.
Yeah, so sometimes it can be very basic, like you have support messages and someone from the support sent a comment about a customer, and it just says, hey, this is the connection key for this user, and here with simple tokenization, you can identify the key and say, okay, in this comment made by someone internally, we can see a key of one of the customer, and this comment is actually accessible publicly on the internet by querying the API in a specific way.
So what are there any good ways to prevent this? I mean, a lot of it is just process and make sure that you don't put this in these messages. Yes, sure, I get that, but we all make we all make mistakes. Like, and I know, like, internally we use Slack. Sometimes you put a message in, but I know that if I delete it, it's actually getting deleted. But do you have any pointers on that? How to prevent, like, solving things, yes, but how to prevent these kind of situations?
Yeah. So first thing, I would say, like, training is very important. We are building resources to help developers get better at protecting GraphQL and creating safe GraphQL APIs. So I think training and awareness at the first step, and then implementing all the best practices. We are pushing hard at Escape toward developing those best practices for making them available to the wider community. And I mean, once you start understanding what are the common security flows, it's a first step towards actually mitigating them and protecting your endpoints in production. We also have an open source package which is called GraphQL Armor, and this open source package can be installed in one line of code, and it actually implements a dozen of best practices out of the box for any GraphQL endpoints in order to avoid this kind of security flows in production GraphQL. Very easy to use, so I encourage the community to check it out.
Yeah, sure. If you have anything to share, feel free to either put it in the chat or something like that, and we can pass it forward. For everybody that has more questions, if you're watching through Hopin, there is a speaker page, and every speaker, almost all the speakers, have their LinkedIn profiles and Twitter profiles connected. So feel free to connect with all of the speakers if you have more in-depth questions, or you're like, hey, this is a specific edge case that I don't want to scream out into the world because, hey, maybe we're vulnerable. You don't want to say that out loud. I get it. But just to gather information specifically through, for instance, these folks that know a ton of GraphQL. I just played around with it. I haven't used it in production because I didn't need to. But if you have questions, feel free to connect to each and every one of these speakers directly through LinkedIn or Twitter, or drop in our DevSecOn Discord, because people are happy to share, because we're all a great community, and hopefully we can do that even more. Antoine and Tristan, I want to thank you for this insightful presentation. I will take you offline now, and we go ahead with the next speaker.
Thank you very much, Brian. Thank you, Banana.
Thank you, Brian. Thank you, Banana, for having us today.
Thank you.
Cool.